So, good afternoon, dear colleagues. I'm very pleased to be here and to take part in this great meeting, for which I'm very grateful to Professor Pinbaum. Thank you, please. I'm glad also to present our common work with Professor Patel, who is also here, and with my Ukrainian colleagues. So we are talking about presbyopia. And I think unless we treat or invent effective and safe therapeutical method of treatment of presbyopia, maybe thanks to efforts of Joanna, I think it will be taught tomorrow. I think we will talk about surgery in the presbyopic treatment decades and decades further, if not more. But one factor is absolutely paramount for all these kinds of treatment is refractive index of the cornea. But what do we know about it, and what do we know about a change about this surgery? What we really know is that endothelial cells maintains the water content of the cornea, that is hydration. And the loss of endothelial cells is still a problem during and after the surgery. And loss of endothelial cells leads to hydration, and this leads to the fall in refractive index. And this also has an impact on the whole refraction, according to the vast majority of papers. But interesting, how much does refractive index is expected to change if hydration should increase? That is the question. It has been known for centuries that refractive index of solution depends on water content, that is, of concentration of solution. The more water, the less refractive index. And this graph, you can see on this slide, shows the percentage water content and its connection with refractive index, according to the late Irving Fett, the founding father of corneal biophysics and other authors. But first, let's turn our look to refractive index of the cornea by itself. Nevertheless, it's a very important factor of the eye and influences the whole refraction. It's incredibly known about it in the literature, and all refractive index estimates which were achieved in the 19th century are shown on this slide. And as we look on this slide, right low, we can see that in the 20th century, just a handful of investigators gave their own estimates of refractive index. And interestingly also that all these estimates were achieved less than 10 eyes, and all these results were achieved ex vivo. Since this century, it has been an interest in assessment of refractive index in vivo. And as we look on this slide on the top, we can see that refractive index is the highest on the epithelium. And then it decreases as we enter to the deepest layers of the cornea. But to enter to these deepest layers of the cornea requires resection, which in turn disturbs corneal equilibrium and water content and refractive index also. All known refractive index estimates were achieved by using contact reflectometry, designed by, according to the principles of contact refractometry, designed by Abe when he worked for Zeiss company in the 19th century. And even this device, left bottom, announced to be corneal hydrometer, which can achieve the refractive index estimates directly from the cornea. It's also the kind of invasive method. So, it's a question, can we actually estimate refractive index of the cornea non-invasively? And then we turn our look to optical pachymetry. This classical method, which has been around for more than half a century, is non-invasive, and the question which we put in front of us was, could this optical section of the cornea hold the key of estimating of refractive index non-invasively? But it's theoretically. But will it really work? That was the question which we wanted to find out. Oops. Some of this picture disappears, but I try to explain. Okay, some formulas disappears, but just go to the basics of optometry. We know that optical pachymetry measures the cornea and measures the cornea thickness of the cornea, but not directly. Corneal thickness could be derived from proper geometric formula according to nomogram, and we also know that the angle of incidence on the cornea, let's say increasing of the angle of the incidence, will increase the optical section of the cornea. And the formula we need for accurately calculate the corneal thickness will depend on our viewing cup. And that was a formal geometric formula and another formula, and this formula, I hope we will find it and show it later maybe. These formulas put together are actually one simultaneous equation which show us that ratio of two optical sections of the cornea actually is the function of refractive index for fixed angle of incidence. And also to prove our theoretical subjection, we made a study. And our study was threefold. The first part of this study was calibration, a bench test which was made on 7 rigid contact lenses. It was made by one masked novice observer. We wanted to prove our theoretical assumption. And the next part, better to say 2 parts, were our in vivo study. It was made on subjects. It was made on 153 right eyes. It was made by 2 observers, masked observers. Why? Firstly, to actually show that our theoretical assumption proved and actually show the refractive index estimate of the cornea, and also to find the inter-observer error. And thirdly, we wanted to measure refractive index before and after the surgery. Also, this study was made by 2 observers. Yes. So after a couple of adoption to the pachymetry, device was calibrated and formula was derived. This formula is shown above, and you can see the relationship between the ratio of 2 optical sections of the cornea A2 to A1 and refractive index of the cornea. And on the right you can see the graph which also shows the correlation between the refractive index and optical sections of the cornea, which also in turn proves our theoretical assumption. Yes, refractive index of the cornea could be derived from this method. What about our in vivo study? As we can see here, there was a little difference between estimates achieved by 2 observers. But when we look at this graph, on the right we can see the small systemic difference between them. What does it mean? It means that these 2 observers, we think, they were using not the same criteria when they interpreting or assuming what was considered the doubling of the corneal optical session. Yes, this method is not 100% objective. Yes, this method is not lack of systemic difference at all, and this systemic difference is based on visual perception. But the question is actually, will this systemic difference will have impact on our outcomes? If we see on these two graphs, we can see that two observers were fairly consistent. There was a difference between them. And then we can see that there were no correlation between refractive index estimates and age according to two observers. When we look on the vertical part of graphs and we look on these figures, we can see that the refractive index estimates we achieved were much higher than previously estimated. What about our practical part of the study before and after the surgery, after phacoemulsification? There were good agreement between two observers. We can see on this graph. And while the first observer hasn't shown any difference between estimates before and after the operation, according to the second observer, there was a small but still significant difference between measurements. So what that shows us? That shows that the refractive index increased after the surgery. So it tells us that hydration decreased. So it was absolutely the opposite that was expected. When we look on these two graphs, we also can see the correlation between the refractive index change after the surgery and preoperative refractive index. There were no difference between two observers. And interesting fact that when the refractive index before surgery was above this point, 1.2405, refractive index tended to decrease after the operation, and oppositely, when it was lower, it tended to increase after the surgery. We have no any logical explanation for this fact. And also we can see that the change in refractive index was between these 2 points, between minus 0.015 and plus 0.205. And this also could have impact on the refraction after the operation. But for how much? According to standard models of eye, it's predicted that the refraction of the eye could change about 1/2 diopter if refractive index of the cornea changes by 0.2015. And that's why we can say that according to results we achieved in our study, we can have unexpected refractive changes, unexpected errors due to changes of refractive index of the cornea. Thank you.